Okay, we are beginning chapter 6. This is video 1. It will be rate of change. Why are you not wanting to cooperate today? Oh, let's see. Just minimize this. There we go. We're going to begin by looking at the activity on page 308. We're going to do that together. Looks like this. Exploring the rate of change. Rate of change is very much like when we are finding the function rule. It is also going to be very similar to the slope as we begin to talk about slope in this lesson a little bit later on. We're going to look at these people on the ski lift at point A, point B, point C, and point D. You can either look on the screen or in your textbook. You notice we are on page 308. The first question it says is, what is the vertical change from A to B, from B to C, and from C to D? Vertical change is up and down. Okay, so when we're looking at the vertical change from point A to point B, it goes up from 40 to this mark right here, which we're not sure of what it is, but since it becomes between 40 and 60, we can assume that it is 50. So the vertical change between A, which is at 40, and B, which is at 50, is 10. Okay? Looking at the vertical change from B to C. Remember, B was at 50. C is up here between 80 and 100, so that's at 90. So from 50 to 90, that's 40. Okay? And then lastly, from C to D. Well, C is again at 90, and D is at 100. So from 90 to 100 is 10. Okay? Now we're going to look at the horizontal change. Horizontal looks like the horizon from A to B. So A is here at 20. B is here at between 40 and 60, so that is 50. So from 20 to 50, that is 30. Then we're at B, and we're going from B to C, which if we draw down, it goes from 50 to 80, and 50 to 80 is 30. And now from C to D, we'll go straight down. D from 80 to 110, that again is 30. Okay, now we're going to do the ratio of the vertical to the horizontal. Okay, Charlie? So from vertical to horizontal, A to B. Vertical is, Charlie? 10. Horizontal, Heather? 30. Okay? Vertical to horizontal, B to C. Okay? Vertical, Maverick? 40. Horizontal, Chloe? 30. Okay? Now from C to Z, vertical to horizontal. Vertical on C to D, Nathan, is 10. And horizontal from C to D, Lila, is 30. Okay? So there are our ratios. We want to write our ratios in simplest form. So 10 over 30 would simplify to 1 over 3. 40 over 30 would be 4 over 3. And 10 over 30 again would be 1 over 3, or a 1 to 3 ratio, a 4 to 3 ratio, and a 1 to 3 ratio. So when we look at question number 4, we've just answered question number 1, question number 2, and question number 3. So when we look at question number 4, which section is the steepest, and how does the ratio for that section compare to the ratios of the other sections? Okay, well, which section is the steepest? If you just look at the picture, this is pretty steep, not so steep, pretty steep, not so steep. Well, since we're only looking at section 1, 2, and 3, which one do you think is the steepest? Yes, Eric, I would agree that section BC is the steepest. What do you know about the ratios of A to B, B to C, and C to D, or B to C in comparison to the other two? It is the largest ratio. Okay? So as we look at that, and as we move into our note section here, we looked at the vertical change. Sorry, we looked at the vertical change, which is vertical. And we looked at the horizontal change on our ski lift. And we looked at the ratio of vertical to horizontal. And we looked at the steepest section. So now we're talking about rate of change. The rate of change, which is what we found in this, the rate of change can be found by the change in dependent over the change in independent. Or how else could I say those things? What do you think, Zoe? Change in dependent is the change in the vertical, and the change in the independent, what do you think, Kylie, is then the horizontal. Okay, Matthew, how else could we say that? The vertical is the X or the Y. It is the Y. And the horizontal, Cole, is then the X. And we're going to talk more about that as we continue to look at that later. We're going to look at example 1. Example 1 on the top of page 309. You can follow along here with what we have. We just talked about the rate of change, the ratio of two quantities that are changing. And now we're going to talk about the rate of change using tables. Okay? We're going to talk about the computers. You have the computers on your worksheet. Okay? The rate of change. Let's look at the rate of change between day 1 and day 2. Okay? From day 1 to day 2. What's the rate of change? It goes from 60 to 75. What is that rate of change, Brandon? It is 15. Okay? I think on your worksheet, I asked you, here you have the chart. I want the rate of change between day 5 and day 2. Okay, let's look. Here's day 5. Oops. Here's day 5. And here's day 2. Okay, rate of change. Remember we said that is the vertical versus the horizontal, or the Y versus the X. This would be my X, and this would be my Y. We know that from our function tables. Right, Kelly? Okay, so Noah, what's my Y change from day 5 to day 2? I went from 75 to 120. Or since I'm going from 5 to 2, it's actually going to be 120 minus 75. How much is that? Well, it's at least 20 to get to 100, and then 25, so that's 45, correct? Okay, and what's the rate of change in my X horizontal? Remember, it was from 2 to 5. Peyton, from 2 to 5 is how much? That's correct, it's 3. So it's 45 over 3. Can that be simplified, Max? Yes, 3 is a common factor, so I get 15 over 1. Isn't that what I got from day 1 to day 2 was 15? So my rate of change is still 15. What does that, is that true every time from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 5? Yes. What does this 15 represent? What does the rate of change represent? It tells me for every day I pay $15. So it's $15 per day to rent my computer. Let's look at this one together. You don't have this on it, but I want to walk through it. Is the rate of change for each consecutive mileage amounts the same? Well, let's check. 30 to 42. Notice we're going up here by what? We're going by 50, right? 50, 50, 50. What are we increasing here by? 12. How about here? 12. And how about here? 12. So is my increase the same? Yes. And it tells me how much I need to pay per mile. Okay, or 1 mile, I will pay this much. Okay, so when the rate of change is constant, it becomes known as something else. We're going to stop our video there for just a moment. I want to make sure that I'm covering. I think I need to do one more thing here. Let's look at example 2. Let's look at the graphs. I believe I need to do that. Rate of change. Let's go over here and let's look at our graphs. Okay, examples using graphs. We have a moving automobile and a motorcycle ride. Okay, on your notes, here's where we're at. Graphs, rate of change. Okay, here we are on the graphs. When we're looking for this rate of change, what did do you remember what we used? Do you remember what we have been using to find our rate of change? What can you tell me? What can you tell me, Hannah? The rate of change, we're talking about the vertical versus the horizontal. I want you to notice the slope here, or the way the line is going. We read graphs from left to right. You notice that these graphs are moving in an upward fashion. Since they're moving upward, they are considered positive graphs. I'll talk more about that in just a little bit at the end of our video. Okay, so here, rate of change. It is the vertical change which is the y, over the horizontal change. Which is the x. Okay, so let's look at these examples we have here. Okay, we need to find where is this line crossing the axis here. Let's look at our motorcycle ride. This is moving automobile. Let's do the motorcycle ride first. Okay, where is it crossing? It crosses here, and it looks like it's crossing right here, we'll say. Okay, remember it's the vertical over the horizontal changes. Here's my point right here. That's at 400. Here's my point up here. That's at 300. Or, I'm sorry, 700. So the difference, or the change between 400 and 700 is 300. Now we go down here. I'm at 20, and I'm at 36. I need to find the rate of change in the horizontal, which is 20 to 36, and that is 16. And then I simplify to get my rate of change. If you look at the moving automobile, okay, quick check number 2. Let's look at that one. Okay, quick check number 2 was the moving automobile. We need to pick 2 points, just like we did here, 2 spots where we felt it was crossing and we could see. Okay, it looks like it's going to cross right there. Looks like it's crossing right here. Looks like we could use here. Looks like we could use here. We can use any of those. Okay, and here I have 0, 0. I have 2, 100. I have 4, 200. Or I have 5, 250. Which times and distances would you like to use? What do you think you want to use? What do you think, Logan? You want to use 2 and 100. Okay, there's one. What would be another one you want to use, Matt? How about 5 and 250? Sure. Remember, it's the vertical over the horizontal. So what's the change from 100 to 250? That's 150. And how are we doing that? We're subtracting those, okay? And what is the change, the horizontal change from 2 to 5? It's 3. So 150 over 3, I'm going to simplify that to 50 over 1. That means I'm going 50 miles, that was this change, that's the label, per 1, what was my horizontal change? Hour. Okay. Rate of change. Let's finalize just a few things here. Notice my signs here. Slope is positive. Slope is positive, it's moving upward. Slope is negative, it's sloping downward. Okay? We've already done finding the rate of change on a graph. We've picked 2 points where the verticals meet together. Okay? And we've decided to find the change in the vertical and the change in the horizontal. Okay? I believe that's where we're stopping today. That concludes video 1.